Hello, everyone. Let's give it a few minutes for everyone to join. All right, let's start. So, my name is Rejith. I'm the co-founder of Cloud Control. And Sanjeev, why don't you introduce yourself?
I'm Sanjeev Kumar. I'm heading the product development at Cloud Control.
All right. So let's get right to it. So today we are going to cover Postgres. And Sanjeev, why don't you give us an introduction about what we are going to do and what we are going to see today?
Today is a great topic, I would say. The Postgres HA, and goes without saying that Postgres is one of the most popular database, especially the people who are trying to migrate to the cloud. And one of the challenges everyone faces that how to run the Postgres is in HA mode. There are three solutions out there. We analyze all three of them, and the one that we are presenting today is the best solution, which we consider that based on the PG auto-failover. This was another open source solution, and I'll go into some details that why we consider this is the best solution. Um, but let me just quickly tell you about other solution which is out in the market. One is that the Postgres community itself, very rudimentary, lots of manual steps and all. We tried, but it doesn't ours like work perfectly as to satisfy and even the Postgres community. The next solution that we have explored, looked into, is by Petroni, and that has dependency on to add some external components like etcd or maybe Zookeeper to keep the nodes in sync. So today what we are going to present PG Auto Failover, which is by Citus Data. They started the company in 2010. It's fully open source, bought by Microsoft in 2019. And it is good to see the company like Microsoft is investing in the open source community to bring these type of capabilities to the market. What we are going to demonstrate that, yeah, you can go through the PG autofailover documentations and tons of pages and do it manually. Most of the documentations are geared towards implementing them on the virtual infrastructure. What we are going to show you with our platform, AppZ platform, which I will cover in some details later. You can deploy the PG auto failover in a single standby architecture, meaning one read-write database, another read-only, and there is a monitor which will be kind of like it does. Uh, on a Kubernetes cluster. In this case, the Kubernetes cluster in use would be AppZ platform Kubernetes cluster, but this Kubernetes cluster could be any managed Kubernetes in the cloud, AKS, EKS, or even on-prem Kubernetes cluster, maybe from the Nutanix or Rancher or any provider. Just to add one more sentence, that why we consider the PG auto failover is the best solution. That the Citus data, what they have done is they use Postgres itself to orchestrate the HA. And by that I mean is that the monitor which you see is another Postgres server node which is controlling the primary and the secondary, and there could be more of the secondary read-only database, and it's always like the synchronous replication. So we found the solutions to be like much more mature and where you can run your applications with full resilience. So Rajat, Now, that's the kind of like the primary aim of this today's webinar. Now, the cluster that we will be covering on which this will be deployed, the two components are already deployed. One is Vault and another is Adminer. Just a quick brief intro about that. Vault is the HashiCorp Vault, which will be used for the secret management in throughout the process. And because you will be seeing that everything is getting deployed using the GitOps process with the AppZ platform. And what it means is that you don't have to know the details about the Kubernetes architecture. You don't have to know the Postgres or even the PG auto failover. You simply clone a repo or fork a repo and start deploying the PG auto failover right away and deploy the applications on top of that. So a lot of kind of like uncover in this process. And the vault will be managing the secrets throughout this process. And Adminer is the PG admin interface, which we will be using to demonstrate that yes, you are able to connect to the database which is running on the Kubernetes cluster, whether primary or secondary, and you should be able to do a transactions and do the validations that how the PG auto failover is constructing the cluster in the read write and the read only mode. Other two components like the PG Connect and the Spring Boot application. PG Connect is another layer that we will be adding. The idea for the PG Connect is that once a Postgres is running in the HA mode, there are two options for applications so that application is aware of uh, the entire cluster and the read write and the read only endpoints. One options that we explored was the libpq, which you can embed in the applications and you can provide multiple URLs for the endpoints. But again, in that case, you have to modify the applications. What we found out that we have built PG Connect, which is based on the HA proxy, and it keeps monitoring the cluster and exposes the read write endpoint as well as the read endpoint so that you don't have to make change in the applications. And we will be going into the details like how this orchestrate and how easy it is applications to start consuming a Postgres HA database right from the repo itself. So Rajit, like let's get going.
All right. So why don't we get into the details of how the Postgres architecture looks like in deployment, right?
Yeah.
So yeah, why don't we explain this? I mean, I know we talked about three different nodes, monitor and PG Connect and the application. Let's go over the roles of each one of those and how we are orchestrating that.
That's a very good point, Rajit. So on the right hand side, if you see that there are the multiple nodes, and this is kind of like this is the PG auto failover in motion, I would say. Uh, and what we are bringing is that most of the documentation talks about deploying on a virtual infrastructure. We have taken their source and customize it to fit into any Kubernetes cluster. What you will be seeing today on the AppZ platform Kubernetes cluster, which is the micro K8S implementation, but it could be any the Kubernetes cluster of your choice in any cloud. Now, the PG auto failover, the deployment, which you will see, will create one monitor node. That monitor node itself is a Postgres database, and it monitors the rest of the node which came out, which comes out as the primary, which is the read write database, as you can see here. And there could be multiple secondary databases. Today, we will be demonstrating only one secondary database, and all these are getting orchestrated by the Postgres image that we will be downloading from our library, and it will get deployed as a stateful set with three replicas. First replica, or call it like the pod zero, node zero becoming the monitor, and the other two becoming the primary, and another become the secondary. Now, although we will be demonstrating this on a Kubernetes cluster, but we have full capability to do the exact same thing on a virtual infrastructure if that is what your requirement are. So this covers kind of like the right hand side, the entire PG auto failover orchestration, and you will see that everything will be happening with a single click as we will be doing the demo. Now, as we move to the left side, as you can see the PG connector. This is the image based on the HA proxy, which is looking into the entire cluster, doing the right query against the cluster to see that where is the primary read-write database and where are the secondary databases, and exposes those endpoints so that applications can simply consume them without knowing the location of the database. So this whole architecture we will be doing the demo. First, we will deploy the Postgres HA mode, then we deploy the PG connector, and then we will deploy the sample Springboard application. And in between, we will be doing the verification using the adminer to make sure that everything is functional as you go along.
All right. So, Sanjeev, earlier you mentioned about the two types of connections that we can make from an application. So, and we talked about the changes in the application. So, let's say if somebody wants to use this without making any changes in the application, what are they? I mean, they can still use it, right? Use it without any changes, but there are some disadvantages, right? So, can you kind of touch on that?
No, absolutely. That's a good question. And as you can see, now one more thing I would like to mention is that all the artifacts that we will be displaying and all the repository that we'll be mentioning are public. So you can go and check them out. Even the sample application that we have built. Now, in the sample applications, you will see that it is consuming two connections. One is a read-write connection, and another is a read-only connection. We understand completely that not applications, especially some vendor applications, are not designed to consume a read-only connections, and that's perfectly fine. So in that case, like application will be simply connecting to the read-write database and posting the transaction. Only one disadvantage is that if applications is very read intensive, that means like application has a reporting module and which is continuously reading the database, that puts the load on the primary database, which has to service the transactions, that means the write as well as the read. And again, the read also consumes CPU cycle. So it is advisable, and we will show you that through our sample application how easy it is. And again, in this case, the PG connector is exposing a exclusive read-only connection, and that load is getting distributed across the multiple secondary node. In the cloud terminology, they are called the read replicas. And most of the reporting can go directly to the read-only connections and consume the resources from the secondary database. So that's advantages, and definitely modern applications are coming up with this capability so that they have two connections and their transactions are aware where to go to, whether to read, write, or read.
So let me understand this. So when if I don't make any changes in the application, I have only one data source, and that will be pointing to the read write port of PG connector. That means all the calls are going to the master or the primary,
That's correct.
right? And
That's
we are not able, in that case we are not leveraging the other cluster other members for reads,
resources of other members. That's correct.
right?
Yes.
So if I were to make the change and say I use one data source for read write and another one for read, so the load will be distributed across multiple nodes.
Absolutely, absolutely. So yeah, if you know your get calls, the get calls are not committing transactions, you can direct them to the read only, and that's what we will demonstrate through our sample application.
All right. Now, and again, you touched on a little bit. So can you give us an idea about, see, in the deployment that we're going to do today, we're going to use Kubernetes cluster, and it's going to be deployed as a stateful set, right?
Yes.
So, and can you give us an idea about what does it mean for a developer? When it comes to stateful set and how the pods, the different pods are going to be used.
Yeah, that's another great question. So, if you have some familiarity with the Kubernetes architecture, a stateful set means that it has kind of like storage attached, and if you are attaching the if you're deploying the stateful set with multiple replicas, each replica will have the storage attached. In this case, we will be deploying with three replicas. So ideally, like in this scenario, you should have a Kubernetes cluster with now at least three worker node, and that is what we will be demonstrating today. So that each replica will go and sit on a separate Kubernetes node, and in this case, master will be sitting on one worker node, and the primary and the secondary would be on the second and the third node. Now, this architecture gives you complete like the failover the capability, the especially from the master point. If the master goes down, no problem. The transactions, like the applications, will still continue. In fact, one thing I would like to mention is that the Node Zero monitor that you see here is a bidirectional communication it makes from all the primary nodes. So it is continuously checking the primary node whether it is live, and the same way the nodes, which are the secondary, primary, and secondary nodes, they are also communicating with the monitor node, and this whole orchestration is done by the PG auto failover. Again, definitely kudos to them to bringing a solution which is Postgres based and providing the Postgres HA capability. So again, coming back to the stateful set, Rajat, like the stateful set, the Kubernetes architecture itself provides the resilience from the failure perspective. And with the PG auto failover, we are kind of like taking one level up in the sense that a, a pod, or call it a node, which with a persistent storage can seamlessly getting deployed on the nodes, and as well as kind of like exposing from applications perspective, presenting a complete resilient and HA architecture.
All right. So from what you just said, is it safe to say that for somebody who's familiar with Kubernetes, here we have Node 0, Node 1, Node 2, and Node 3. For a Kubernetes engineer, that would be Pod 0, Pod 1, Pod 2, and Pod 3, right?
That's correct. That's correct. And another thing, since you touched upon this, I would like to mention the platform. Apart from the PG Auto Follower, we are using our platform, which is a product available in AWS Marketplace. We can go into some details later. Our the platform mantra is that use Kubernetes first and learn it later. If you want to learn it, of course, it's a vast subject, it is evolving subject, you're free to do that. But what we this platform, the AppZ platform, brings to you is to start using from the day one. Like, you don't have to understand the complex architecture, a stateful set, deployments, replica set, and all those details, ingress. You start using it right from the Git repository. It is available in the marketplace. We'll go into some details like the later. But Rajit, you are right. The node 0 and like all these represents the pods, Kubernetes pods, but we have capability to deploy in the virtual architecture also. So that's the reason I say that let's call it like the node. That way, it is a common denominator across the Kubernetes architecture as well as the virtual architecture. But today we'll be covering the Kubernetes.
All right. So now about the day two operations, right? So one of the key things that I'm sure everyone has in mind is when the primary fails, is it necessary to do any manual steps, or in this setup, is it completely automated?
This is completely automated. That's the beauty of the PG auto failover built by the Citus data. In this case, what will happen if the primary fails? The monitor will promote the secondary as the primary. Again, you will see the status of the events, that how they manage it. Once we go through the demo, you will see that user does not have to do anything. It will happen automatically when and just to let you know that if the primary comes back, then the secondary is already promoted to primary, and the secondary all primary, and the primary node will become the new secondary node. So this whole the designation, and if you have the multiple secondary nodes, you can have the quorum, that how much which one it gets the preference in terms of getting promoted to primary. They have the whole design to support that. So to answer the question shortly, that user does not need to lift a finger to make that happen. PG auto failover takes care of that.
So what we are demonstrating today is a true, fully automated Postgres high availability setup,
Yes, that's
right?
correct.
Okay. Now, it's already 20 minutes into the webinar now. So let's quickly take a couple of minutes to show where we are going to deploy, right? So let's look at the cluster. So can you give us briefly, the structure of the cluster that we're using?
Yes, and as I was mentioning about AppZ platform, our AppZ platform has it is available in the marketplace, and today's deployment will be happening on the AppZ platform, running in the Nutanix hardware. We are partners of Nutanix, and they have provided a lab to us. That is where it will be running. It is Nutanix AHV platform, where four virtual machines have been combined together to form this AppZ K8S cluster with microK8s. It's a Kubernetes 19 version. That is what is running. And as you can see, the master node is running some of the AppG platform core components, like the dashboard, platform, etcd. And this enables the GitOps operation, as you will see later, so that you don't have to know the complexity of the Kubernetes architecture, as well as the some of the underlying open source technology, be it like the Postgres or the Adminer or the PG Connect. You simply start consuming our template, uh, their infrastructure template, their application template. In today's case, we'll be using the Postgres HA template, which is based on the PG auto failover. We will be using another template, PG Connect, which orchestrates the connectivity for the applications, and using another template, which would be the Java Spring Boot, on which the applications will layer. Now, all these applications will be running including the Postgres like HA. All the three pods will be running on the node 0, node 01, 02, 03. There are three worker nodes on which they will get distributed, and that scheduling distribution will be handling by the Kubernetes as it is designed to do that. Now, as those things are happening, we have our dashboard, which Rajit will be sharing. It has full visibility of with observability, that how these things are happening, how the applications are getting built, deployed, how the secrets are getting pulled from the vault. All those details will be there. And also, the if applications needs an ingress, meaning need to be exposed outside, we have ingress controller running on the platform, which will enable like either applications endpoint to be exposed to outside. So in nutshell, this is we present a complete like the GitOps platform with the CI/CD pipeline and full observability. That's what we see. So our mantra is uh, start using your cloud, your Kubernetes, your open source component immediately, and focus on your applications. That's your core component that you are developing as a company, as a as a next level of the platform that you want to build. Focus on your applications, and AppG platform brings the cloud, Kubernetes, and all the complex technology to you to start using without learning them.
All right. So let's get to the demo. So let's quickly recap on what we are going to show in what sequence, right? So Vault and Adminer are already running. So we're going to start with the Postgres HA 3-node cluster, right?
That's correct.
Um, and then we are going to deploy PG Connect. And then in front of that, we will be deploying a Spring Boot web application.
That's correct.
So let's start. So I'm going to share my screen now. All right. So let me bring in our dashboard. So this is just a view of the Kubernetes cluster. I have to put a filter on my namespace. So I'm going to deploy everything that I'm deploying to my namespace, and this is just a view to what is running there already. So Vault is already running, and Adminer is already running as well. So let's start with the deployment. So first, uh, uh, Sanjeev, why don't you walk me through the
Let's
deployment?
go to the repository, and all these repository are available in the eCloud control. All these are the public repository, and with some documentation also how to use that. So this is the Postgres HA repository. Rajit, why don't you like fork it? So let's fork it to your personal, then we will
Okay.
start. Now let's open the AppZ YAML and let's make some changes. Change the notification email, and, and the namespace will be deployed. Now let me quickly touch upon that. Like as you can say that we are deploying this as a. Let's commit that.
Yeah. So I committed it. So
Yep.
now,
So
yeah, go
so,
ahead.
the image template, the under build section, that is what the crucial here. And Postgres HA 13.13. So we are deploying Postgres HA 13.13 built on top of the PG auto failover image. So we are. This is a like the Docker image which has all the automation, the baked in to go on top of the Kubernetes cluster and get it deployed. There are three volumes that we are exposing. One is the data, another is the home, and the backup. So three volumes that PVCs will get created. And if we go to the properties section, Rajat, quickly, as you can see that the certain properties are defined, and all the passwords will be sourced from the HashiCorp Vault, which is running in the same namespace as Rajat was sharing the screen. We will be deploying this image as a stateful set. Sorry, can you go to the deploy section under the Rajit dev namespace, and with the three replica. And as I said, that the first replica, the pod 0, will become the monitor, and other two would be the primary and secondary.
All right. And we also touch on the volumes. So
Yes. So the volume, as you say, that some of the volumes are the data volume, which and you will see that the mount point is AppZ data. So we have configured so that the known set of the data volumes are mounted with the PVs, and there are certain configuration aspect which is getting stored as the AppZ home, and every stateful image that we provide also has a backup job running, which takes a kind of like the local backup of the data, and that would go into the third volume.
so is that like a snapshot that we're
Yes,
taking?
that's correct. That's correct.
All right. So let's move on. To add the webhook, so
Yes.
I'm going to go to settings. I'm going to go to webhooks. I'm going to add the webhook to point to our cluster.
Yeah, the webhook is our platform is the GitOps platform, and the webhook is one of the method to integrate your Git repository with the platform. That is what Rajit is doing, and this is a public repository, so no token is required. If it is a private repository, then you have to embed the token in the platform to pull from the.
All right. Now let's move on to the setup.yaml.
Yes. So let me explain now, and this is our kind of, I would say, like the cloud control AppZ add on top of the Postgres, and we support this functionality on all other RDBMS, be it like the MySQL or MongoDB. We support across all the SQL as well as the NoSQL databases. What we are doing here is that once you deploy a database in the Kubernetes, you need to create once you deploy a like RDBMS on the Kubernetes, be it Postgres or MySQL, you have to deploy certain user, certain database, certain schema, and that is mostly manual. People log into the database manually, is either directly at the cluster level or using an admin tool. So we have automated that process as well. So as you can see, that what will be happening, that the Postgres database that we get deployed with auto-failover will have a pre-configured database. In this case, the Spring Boot DB, I believe that was the name, and a user will also get created Spring Boot Web. A schema will get created. The user will have the roles assigned, and if you look at the bottom section, we are sourcing a, like we call it the database restore. So we are sourcing a dump of the database and restoring it. So kind of like you get a pre-configured database with all the schema tables, the roles, and everything is configured, ready to use. So if you this is helpful if you want to migrate from your on-prem environment to the cloud. You can right away use this repository, use this methodology and the AppZ platform to move your on-prem applications to the cloud, running a Postgres in the Kubernetes cluster or even the virtual infrastructure, whatever your preference is. So Rajit, let's get this.
So I'm going to edit it, and we're going to change the token.
Yes. So this token has to be within the 15 minutes of the UTC time. And this we are keeping intentionally so that the restore will happen only when the token user puts the right token value in with full intention.
All right. So I'm ready to commit, right?
Yep.
All right. At this point, I think it makes sense to kind of show what the flow is. So, can we kind of touch on this diagram on how the flow works?
Yes. So I would say, like, let's start with the right hand side, which is a Kubernetes cluster. And as explained, that in this case we are using the Kubernetes cluster provided by AppZ platform, which is the microcade cluster. Now we are CNCF certified, the Kubernetes first company. So this is our preference. We also advise our clients to migrate to the Kubernetes platform. Although we support the virtual infrastructure completely. Now, this Kubernetes cluster could be running, as I said, either on-prem or any of the cloud providers, either the managed or unmanaged Kubernetes. So from the product perspective, AppZ is completely cloud and the Kubernetes implementation agnostic. Now, as we go towards the left, our platform, AppZ platform, is in the middle, which you will see in the action. And the observability, our dashboard, which Rajith has shown a glimpse of that, but we will look into more details. That we have, I was like two sets of dashboards, and more are getting added. First dashboard is more of a kind of like the dashboard, like developers dashboard, to see that how the build deployment and the runtime logs are running. Our the philosophy is that you should not be log into the privileged infrastructure to understand that how your either application or infrastructure is performing. That's the reason we are exposing everything through an observable dashboard. And then we have the Grafana dashboard with Prometheus, which expose the metrics of the either the pod at the infrastructure level. Now, on top, you can see the AppGS stacks. This is our repository, our so the infrastructure and application components. So in this case, the stack or the image template, which is the Postgres HA 13.3, that is getting used. And this template, as I said earlier, is based on the PG auto failover open source. We have hundreds of such templates across multiple technology, either database space, middleware space, application space, all, and there's like a full list out there. And if whatever technology you are using, either open source or commercial, we have a template for that. Now, what is happening? What Rajit did right now, that as a as an operations team member, you can say that he said that, yep, I want to deploy a Postgres HA image on the Kubernetes cluster so that the my applications team can start using it. Uh, he just creates a simple manifest, AppZ YAML, as you saw, that what he wants to deploy, in this case, the Postgres HA image. And he also gives certain arguments in setup.yaml that once the Postgres is up and running, what sort of the database, user, and all these things need to be created. Now, those information gets merged with the template, which is the AppGS stacks, and this merger happens in the AppG platform, and we will go through some of the dashboard to understand how those things work, and then get deployed on the Kubernetes cluster. So the end result is that as a developer or a operation team member, you don't have to know anything about the Kubernetes cluster. You don't have to know about the complex technology of the PG auto-failover. You simply start consuming it from a Git repository. And since this is a demo deployment, development deployment, there is no approval required. But if it is a UAT and production deployment, we have a workflow manager also built in, which will control that what needs to be deployed and all the verification will be done before the actual action will be taken.
All right. So let's quickly look at the dashboard
Yep.
and kind of, okay. So here is the deployment record. So you want to walk us through this?
Yeah, so let's look at the build aspect of it, the build. And in this case, the build is simply taking the AppG template image from our repository and merging with the parameters which gets passed as a like Git operation in the setup.yaml as well as in the AppG YAML. So those changes are getting merged, and an immutable image is getting built out of that, and that image will be used to deploy on the AppG platform as part of the deployment. And I
All
think
right.
I would be covering more this details when we discuss about the application deployment, which is Springboard, because that will make sense to explain the build aspect.
Okay. And the deployment is successful as well, right? So,
Yeah, deployment is successful. So that using that immutable image that got built, merging the template with the properties which came from the AppG YAML, uh, then at the runtime, the secrets are getting pulled from the vault. And why don't we show a quick show of the deployment YAML? So this is the manifest which you use for the Kubernetes deployment. Again, there are other Kubernetes technology out there, especially in the DevOps space, which ask you to create this type of template to deploy. We are providing this template out of the box and with the full details, kind of like creating this with automation. And you focus on because your manifest, as you saw in the apps YAML, is very simplistic, plain English language YAML, where you can easily do that and you don't have to know the complex architecture of the Kubernetes. We built on the fly this for you as for the record keeping and audit purposes also. And this is the manifest which gets executed on the cluster to build the stateful set PG auto the Postgres that you will see.
all right.
Now also, yep, keep on going. Yep. Now this is the logging. As you can see, the three instances came up, and we have some uh, the details about the infrastructure, and you can say that all the three instances are up. You can see.
I think it's still coming up. I think you can
Yep.
see one running already. So the Postgres is getting initialized as we speak.
Now let me quickly go over that what we are seeing here. Um, our platform, AppG platform, comes with built-in Elastic and the Graylog. And the dashboard that you are seeing is the dashboard on top of the Elastic and Graylog. We call it the log collector. So we have a complete log collector built in our platform, and as the pods, Kubernetes pods, are getting deployed, they are creating certain logs. Those logs are getting shipped to the Elastic using the Fluentd. So every template that we provide, that's on the top AppZ stacks, has the Fluentd integration, has Vault integration, has other alerting and monitoring component integration. So it's a fully resilient image ready to get plugged in. And the platform itself provides the log collection capability. And that's what Rajit was sharing. Again, if as a company you have some other log data platform, we have ability to ship to that as well.
Okay. So now at this point, can we go and check if the nodes are okay through the adminer? So I know we deployed
Yes.
adminer. So I'm going to grab the adminer URL from the adminer deployment log. So I'm going to go into the deployment log here. Maybe log in.
And we will
So
log into the monitor mode. And
okay. So Sanjeev, can you kind of touch on the use cases that we are using the adminer for?
yes, so yeah, Admirers is another great template that we have, because Adminer, in this case, we are running right on the cluster itself in the same namespace. One challenge, which is across all the cloud platform and especially in the RDS space, is there that most of the databases will always sit on the private network. But there is a need in the user community that they want to interact with the database. Interact means like they want to browse primarily. Uh, from the desktop. Of course, the desktop tools is a big no, because if you look into AWS RDS, they say that create a SSS tunnel. So that means that you are bringing another EC2 instance with a SSS tunnel to connect to the RDS, which is running on the private network. We solve this problem by running an adminer image in the on the private network, but our ingress controller is kind of like exposing that endpoint so that you have a fully protected web URL. And when we say protection, that means like we have not only the user password, we have added MFA also on top of that to make sure that unauthorized access doesn't happen. So we have a fully protected web URL to connect to the databases running either on the Kubernetes cluster in this case, you say, but that can also support if you have RDS running on the private network.
All right. So adminer is, as we mentioned earlier, adminer is already deployed. So I'm going to go into the adminer deployment log and click on the URL. So here is a URL. So be taken to adminer screen here. So I'm going to pick Postgres SQL, right?
Yep,
And I'm going to use node 0,
yep,
and the user ID is Postgres. And I'm going to type the password. This was an auto-generated password by Vault, right?
that's correct. Yes,
Okay. And so our adminer is OTP enabled. So it is. I'm going to open my Google Authenticator and pick up the uh, code from there. I will log in. All right, we are in.
yes.
So
So
right
we
now
are
we are
not.
connected to node 0, which is monitor, right?
That's correct. That's correct. So let's explore the PG auto failover
Okay.
node 0. Yep.
All right. So we are going into the PG auto failover.
Let's look at the node first. As you can see that the monitored node data, and again, this is the PG auto failover inside. So like this is a Postgres database, which is monitoring the other two databases, and it has designated them as primary and secondary. And it is the role of monitor to set up the synchronous replication between those two as well. So I see kind of like everything is set up, and why don't we scroll down and see the events that will be, so any type of Now, this table is again, all these are coming to the PG auto-failover. Definitely kudos to them. Like as you can say that it started with a single node, which is the primary node, and as the second nodes came on, it kept on changing their status. And the ultimate quorum is that the node one becomes the primary and node two becomes the secondary. If anything happens on the primary node, the secondary will become the wait primary mode, and they have a kind of the sequence to monitor that. It's a beautiful the way they have designed it, and kind of like and we are exposing it to a miner to show you that how kind of like this works, and this is a fully resilient Postgres HA database.
All right. Where do you want to go next? Now, so the cluster is up and running, and what's next?
Let's deploy the PG Connect because we want, before we deploy applications, we want to expose the connectivity, one read write and another the read only.
All right. So I'm in PG Connect repo.
Yeah, let's fork it and then we will explain.
Opening. So I need to first set up the webhook, right?
Let's set up the webhook here.
Pasting the webhook URL for the cluster and changing the content type. Add webhook. I'm going back to edit the AppZ YAML. So go ahead, Sanjeev.
This is a deployment, and as you can see that we are exposing two ports, 5000, 5001. 5000 will become the read write port. 5001 is the read only port, and we have listed the databases, the primary and secondary. In fact, the multiple databases can also added here. We will extend that feature in like the next demo, and the this image continuously poll the cluster to see that which database is in the read write mode and kind of like expose it into the 5000 port, and all other databases will be exposed as a read only database on the 5001.
All right. So I'm going to just commit this, make a change and commit, right? No, I don't have to. Okay. So let me change my notification URL, I mean, the email. And namespace.
That's it.
And so I'll show the diagram again. So we are deploying the PG Connect here, and then we'll move on to the application, right?
That's correct. Yeah.
So the significance of the two ports, right? So 5000 you said is read write, and
Yep.
5001 is read only, right? And 5001 is the one that is round robining among the nodes so that you get load balance
That's
to read,
correct.
right?
That's
Okay.
correct. Yep. Yep.
All right. So that deployment, let's check the status of that. So let me share
And
my.
as I said earlier, that another solution is given by the libpq. Again, that if application is able to do that, in that case, applications has to construct the multiple URL in the JDBC connectivity.
Okay. So looks like PG Connect is also deployed, and there are two instances of that. So even for the PG Connect, we are making sure that it is resilient by having two nodes running or two pods running, right?
That's correct. And this is a stateless deployment. So that's the reason like we can have, there's no kind of like the volume involved. So it makes sense. For most of our deployments, which are stateless, we deploy two replicas. That way they are available on both the cluster in case one node of the cluster goes down.
All right.
That's what the load.
So at this point, we can deploy the application, right?
Why don't we connect to the database, which is the
Oh, okay.
primary and secondary using PG Connect? Because I want to demo that the actual databases are up and running.
All right. So I'm going to duplicate this tab and go in here and then log out. And I'm going to go to the next node, right?
Go to the PG Connect 5000 port.
Oh, PG Connect. Okay, that's right. So PG.
Yeah,
So go to
PG Connect
5000
5000.
port. So
Yeah.
that'll be okay. The password. Let me grab the OTP code. Right. I'm in.
Yeah. So and let's open another connection and connect to the PG Connect 5001 port so that we have a connections to both read write and the read only database. And then we want to.
Okay. So here I'm going to use 5001.
Yep.
Same user.
Yep.
Waiting for the OTP to refresh. Okay, got the new one. All right.
So now we have two windows open. So we are connecting to the primary database as dictated by adminer and the secondary database as dictated by adminer and kind of like expose via the PG Connect. So let's look into the primary database first, which is the PG Connect 5000 port. Look into the data. And this is the Spring Boot.
Let me log in again. I think I accidentally clicked the log out.
Oh,
So
okay.
that it doesn't like. Okay. So we have
Yes. So this is the account table which got restored. So let's open the account table, select data. It has 10 records. Now let's open the account table on the secondary database as well. So go to Spring Boot Web, the account table, and this is a read-only database 5001. Let's commit a transactions on the read-write database.
okay. So I'm back to 5000 port.
Yep,
I'm going to edit one record.
yep.
So I'm going to make it David 2
Okay.
and save. So
So
David
this
2.
happened. Let's verify it on the 5001 port, which is the pointing to the read-only database.
Yeah, it's got replicated.
Yep. And let's try to commit the transactions on the read-only database.
Okay, I'll try to make it 3. Save.
And we are
So
expected this to fail because this database is in the read-only mode. Okay.
all
So
right,
let's
go back. Okay, looks like its cluster is up and running,
cluster is
replication
up
is
here,
working, all set, right?
and the
And
PG connector is also. So let's deploy an application now.
all right, so I'm going to go into this window here. I'm going to go to the application repo and clone it or fork it. That is a Spring Boot Web PGSQL application, right?
Yes, and this is also a public application, so you can take a look how we have. This is just a sample application, but it consumes a read-write connection as well as a read-only connection.
Okay, so I'm going to go to settings and
Rajat, you have to fork it.
oops. Okay, thank you. Let me do that. Okay, so I have forked it now. So I'm going to the settings and adding the webhook. All right, going back to edit. So it's a Spring Boot application, right? We
Uh,
have, yeah, go ahead.
yes. So while you are modifying the changes, and you can see that it's a public repo, so people can take a look. And I'll just point out to the primary and the secondary database at the bottom.
Yeah.
And it is using our image template Spring Boot V2 on the top, Rajit, if you can, line number 9. Okay. Now, from a company perspective, we want, as a developer perspective, we want our client to focus on this aspect. Like, yeah, this is a like this type of application they need to focus on without worrying about the cloud, Kubernetes, and all, because the rest of the things, like we are providing as a pure GitOps, which they can consume right from their Git repository on their whatever cloud infrastructure they choose. So they should be focusing more on application. And here is the sample applications and the similar type of application. They continue building it. And as you will see that we will be deploying this, okay, we can deploy 2 replicas also here on this. And so why don't we commit this, Rajit?
Okay, so our team is telling me that I made a mistake. So by the way, our team is helping us through Slack channel. Uh, so let's go to the webhook. I did paste the wrong URL here. Look at this.
Uh-oh. I also did not
All
notice.
right. Thanks, Eugene, for helping there. Copy the link. So I'm going to paste the right one. So I'm going to save it. Now back to AppZ
Yeah.
and we are ready to edit now, right? And so it will trigger the deployment. So I'm going to edit. Same changes here. And the namespace. Right?
Yep.
All right. So the commit. All right, we have several questions lined up. So I think once we are done with this we will definitely go through a few of them. We have booked another 30 minutes or so for this. So let's quickly go through this and then we'll cover the questions.
Now, Rajit, it will make sense to show the dashboard because the importance of the build deployment is much more relevant here.
Right, sure.
So the Spring Boot.
Spring Boot is still running, so
Okay.
let's let it come up. So we can touch on this. So this process here. So I'm pretending to be a developer here, and then I committed the changes, and the platform is basically sitting on the sideline and providing the pipeline to deploy, create the image, build the image, create the image, sign it, and then push it into the Kubernetes cluster.
That's correct. That's correct. So this is the application development where we want our clients to focus on, and they don't need to like AppZ platform come builds a call it like the gateway or like landing zone for the cloud and Kubernetes, and they simply start using it without getting into the complexity that how they are architected and how they works. So and the AppZ platform and along with AppZ stacks, which are the templates, either for infrastructure deployment, as you can see that we are deploying a Postgres HA database using the template, and the platform kind of like the brokering that the deployment model. The same with the Spring Boot, which is the like this this is the getting deployed, and applications team need to just focus on their the code.
Right. So it looks like the deployment is done. So the build was success and the deployment is success as well. And we have one instance running of this application.
Yeah,
So I'm going to grab the URL. So I'm going to go into the deployment log, look for the line where it says, look, here is the URL to the application. So here is the app. So it looks like it's connected to both. It's using both data sources.
Yep, and it says also say that both the data sources are online. And as we can see that we had made one change in the data, which is the David 2 through at minor window, PG Connect, and that is getting reflected here. So why don't we make some changes using this UI, edit
Okay.
data or add it?
So my assumption now is, when we pull the data and showing this, it's using the read-only data source, which is
Yes,
separated here.
that's correct. Yes. So all the get operations are going through the read, and all the like other HTTP call like are going through the.
So when I make a change here to 3, say it's using the 5000 port.
5000 per read write. That's correct.
All right. So let's go to the, so here is the 5000 port. I'm going to reload this so I can see that change got reflected here.
Yep.
And I'm going to switch to the 5001 port, which is the secondary, and it's reflected there as well.
So synchronous replication, it is happening between primary and secondary.
All right. So that covers our topic today, right? So anything else you want to touch before we get into the questions?
No, and I just want to specify one thing, that how easy it is. Kind of like within an hour window, we are able to demonstrate the deployment of PG auto-failover image as a stateful set on a Kubernetes cluster, like show the visibility that how the monitor node is orchestrating that, and also put a PG connect on top of that, so that it is easy for applications to connect without knowing that where the URLs are. Again, that also exposes a read write and the read only connections. Depending upon the application maturity, both can be used or one will be used. And then we deploy sample applications to demonstrate kind of like the end-to-end visibility. So that's the value AppZ platform kind of like the brings to you. We What we showed today was kind of like five templates that we have, including the Adminer, Vault, PG Connect, PG HA, and the Spring Boot. Those five templates. We have hundreds of templates for whatever technology you use, whatever cloud you want to use. We are completely cloud agnostic. So reach out to us if you want this demo to be done either in your cloud or on-prem data center.
Awesome. So we have some really good questions. I'm going through them.
I'm waiting for
So
them.
I'm going to start with a very simple one. I mean, it's kind of a logistics question. So will this be recorded? Yes. So the YouTube link is going to stay. And we're not going to delete that. So you can always come back and look at it. Let's move on to some of the technical questions. I see some really good ones. Now, first question is, how will the PG connector know there are multiple secondary nodes?
That's a very good question. So the PG Connect so PG Connect is kind of like querying the cluster, and on querying the cluster directly to the master node to understand that which nodes are available, um, and uh, and based on that, it is exposing them on the 5000. Again, this is simplistic because we had the only two, one primary and one secondary, but we have the ability to expose the multiple secondary node, and also since it is HA proxy based, we can among the secondary nodes, we can say that how much traffic we should be going to where. Because let's think about this way, and I want to give a comparison with the AWS RDS. AWS RDS, when you set up, we have the multi-AG. That means like in the close proximity, you have the two data set, and then you have the read replica sitting in the other regions. Similar type of concept can be the brought in here. You can have the multiple secondary databases, one getting synchronously replicated, others you can set up as a like asynchronous replication. So there may be some lag, but that may be good for your reporting. And PG Connect can connect, like understand all those things and expose all these endpoints, and also route the traffic, that how much traffic will go to the first secondary node, how much traffic should go to the second node, and so on.
And I opened the AppZ YAML here. So this is where we are actually indicating how many secondaries are there, right?
That's correct.
So we are explicitly saying how many secondaries are there to PG connector.
That's
And
correct. That's correct. Yeah, and yeah, we can do it in the comma separated, and you can list all the secondary nodes which are possible. Now, this is one way. In fact, the PG Connect is a generic image, and when I say the in this case we implemented the PG Connect for PG auto failover. But if you have other type of implementation, PG Connect will still work. even for the like RDS, AWS RDS if you are using, and it can expose all the endpoints and route the traffic.
Okay. So there is another question now. Is the PG connector also working as a load balancer?
That's a good question, and I think I touched upon that. So from the primary, so definitely from the primary perspective, it is giving you a read write connection, and it is switching the connection if the failover happens. So you can say that that's one way of the load balancer, but another way you can say that within the secondary nodes there are multiple read-only database, and you can decide that how much traffic you want to like route to. So since it's HA proxy based, you can have the load balancer within the secondary nodes as well.
All right. So we have another question. Uh, how does the DR and backup work, and how does PG connector play a role there? And what happens if a node fails?
Yeah, if a node fails, that's a good question. And if the node fails, then the PG connector, again, like in this case, in this particular demo, the PG auto failover, which is orchestrating, and the PG connect is simply kind of like the watching it, and it knows that where the read write connections are, and it exposes it on the 5000 port. So it's kind of like on a continuous basis. The finds it and expose it. So in this case, application doesn't need to be recycled. The PG Connect also doesn't need to be recycled, and most of the hard work is getting done by the PG auto failover, by the PG HA image, and other layers are simply kind of like using that data to expose the right connection.
All right. There is another interesting question. I think we also spend a lot of time on this. Uh, it looks like the monitor, I'm just extending the question a little bit here. When we look at this architecture, there is only one monitor node. So what happens if that gets destroyed or failed?
And that's a very good question. So first thing is that say, and that's the reason I said that in the earlier that the PG auto failover architecture itself demands at least three nodes. So that monitor is sitting on a separate node than the primary and secondary. So if the monitor node goes down, the all the nodes, including the primary and the multiple secondary, will immediately know that monitor is no longer there, because as I said that this communication between the monitor and all the nodes are happening in the bidirectional way. Uh, but the PG auto failover is designed that even the monitor is not there, they will keep on pinging, but they say, yep, but it will not affect the functionality of the database. So read write database will always like up and running. Of course, if there are two node failure, that's a different question we're talking about. But if the monitor goes down, the all the nodes will continue functioning, continue playing their role. It is just they're not reporting that to the monitor. So from application perspective, this is completely like the safe monitor doesn't come play a role at the time of like connecting with the applications. Uh, but as I said with our image, we are keeping a backup. We have lots of way to recover the monitor node and bring it back up, and so that all the nodes will continue start sending the data again.
All right. So there is another question, which is I thought it's very interesting too. So we are customizing these images to orchestrate the way we are showing in this architecture. So can we kind of touch on that?
Sure. So that's a very good question, and I have a kind of the two-part answer. So yes, we are customizing the image, and as you saw that to make it a true GitOps, and the idea being is that yeah, PG auto failover there is a tons of documentation. If you go through 20 pages of documentation and implement PG auto failover, or you simply start using this image and simply do a commit and put your requirement, what you want to, how many replica you want, what sort of data you want to create, what user want to create, and use it. So yes, answer is that we are customizing the image to give this functionality, the vault integration, logging integration, and all. So and this is available on our AppZ platform. Now the question about the open source, we have we take most of our images are based on the open source, but we also put the custom. We also offer the customization on top of commercial images. I would say like Oracle, a SQL Server, and make it kind of like available on the platform to be consumed. And that customization is more to automate the technology deployment, as well as we want nobody should be logged into the infrastructure to understand that how the technology works. Having said that, the our platform itself and our stack, it's our roadmap. At some point, we will take it to open source, and that's on roadmap, but we are not there yet.
Okay. So Sanjeev, I think you touched on a really good feature of our platform, which is the low touch, right? So,
Yes.
and if you look at my experience today, right, when I was following Sanjeev's instruction, I did not go into the Kubernetes cluster. I did not go into any CLI. I was able to completely manage and bring up everything through Git, right? And related to that, I think there is a question here. What is the significance of the webhook?
Yeah,
Um,
that's
yeah,
a
I'll,
very
I'll bring that slide, so you can kind of touch on
yeah.
that. So yeah,
And
yeah, go ahead.
Rajit, I will answer, but definitely you can supplement that. So in this case, the webhook is playing a role for the I would say like the CI/CD pipeline orchestration. Something has to trigger the deployment, and in this case, it is the webhook, which and most of the SCM platform, be it like the GitHub, Bitbucket, GitLab, provide this ability so that if any change happens on the uh, repository, and primarily it is geared towards the application, so that if I make a change, the change gets picked up and then deployed on a target endpoint. In this case, the target endpoint is our AppZ platform, like the cluster, which it intercepts that webhook and pulls the code from the repository and deploys on the platform. Rajat, feel free to, I think you have more.
Thanks, Sanjeev. So this kind of brings the point, in terms of what we do as the AppZ platform, right? So when we look at Kubernetes today, it's very complex, and people need to learn Kubernetes and also learn how to deal with kubectl or kubectl. So there's a lot of learning curve involved. But at the end of the day, the use case is, you want to deploy your workload. And today we saw a few workloads getting deployed, including a very complex Postgres. Then we did a PG connector, and then we did a Spring Boot application. So what we do is that, we created a GitOps pipeline to manage multiple Kubernetes cluster through by means of a dynamic pipeline. So what you are seeing here is, when a developer and operations personnel makes a commit to Git, we automate everything that they need to do with Kubernetes clusters and manage that for them, and then bring in all the observability as part of the deployment so that they don't have to go into the Kubernetes cluster and look at the pods and look at the underlying logs and things like that. Instead, we bring everything to the observability dashboard that we have. So that's the value add that we are bringing. And the webhooks, the significance of the webhook here is the connectivity from the user input, which is in this case from the developer or the operations. Their input or their intent is being committed to Git, and through the webhook, our platform gets connected. And that's how we know when a user want to make a change. So we monitor that through webhook. So when the developer or the operations engineer commits a change, that change will flow into the AppZ platform through the webhook, and that's when we automatically create the pipeline and all the manifests to deploy and manage that change in the Kubernetes. All right, so let me look at other questions here. So one of the things that came up was, about the backup, right? So we mentioned about the backup. So how does the backup work? We touched on it in terms of the volume. There was a volume that is dedicated for backup in the Postgres. So, Sanjeev, can you touch on that, please?
Yes. So, and I would say like this feature and these type of features we have added. And what the other question was the customization, like to make especially the stateful images are kind of like the hard to manage and from the resiliency perspective. So of course the PG auto failover is providing the resiliency at a cluster level, but at the same time, like we want resiliency at the local pod level itself, and that is what the value the backup is providing. So it is always safe that you take a backup of any stateful image and keep it on at a separate volume, separate mount point. And that's what we are doing. And that mount point could be like residing somewhere else if it is an EBS volume, so that you can retrieve at any point and go back. So that's the purpose of backup. So there's a backup job which is running on a continuous basis on our platform, and which takes looks into the primary data in the volume and takes a backup and keep it. I think we keep a backup for 7 days, and then kind of like it gets cleaned up automatically. So you have the ability, if you want to go back to a previous maybe yesterday's the data, we have the ability.
All right. So, moving on to the next question. So, Jenkins, are we using Jenkins? Because we keep mentioning pipeline. So, let's give clarity on what we are using here for pipeline.
So Rajat, why don't you take that?
Okay. All right. So we are not using Jenkins. So we have a homegrown pipeline based on industry standards. We build the image, we sign it, and we can also integrate with security scanners. And then we deposit the image in a Docker repository, and from there we take the image and create all the manifests required for Kubernetes, and then uses the Kubernetes API to deploy it. And post deployment, we manage it using our observability stack, which is based on Elastic and Prometheus. So we are not using Jenkins in this case.
But we can support Jenkins. That's a separate story. If you have the Jenkins pipeline, we can support that.
That's right. So if you already have something in place, we can definitely integrate with that. Now, the next question is also very interesting, very kind of day two. So now we have the observability. Now, what if I want to manage the Kubernetes cluster myself using CLI, right? So I'll start and then jump in, Sanjeev.
So,
So, so remember the way our platform works. The cluster is yours. You can bring in. We have our cluster builder based on macro K8S. It will come up, it will run on your infrastructure or your account. And you can also add additional clusters like EKS, AKS. A single installation of AppZ can manage multiple clusters across multiple environments or multiple cloud providers as well as on-prem. Now, the cluster is completely yours. So if you have the Kubernetes engineers or that has access to those clusters, they'll be able to use the CLI. We are not altering the cluster in any shape or form. So all the CLI that you have will work and will continue to work. Sanjeev, go ahead if you want to add anything.
yeah, and but my only thing would be that you give the CLI access only to the people who are equipped with the knowledge. And also, even if they are equipped with the knowledge, you should always be asking why they need the CLI access. Because if they log in as CLI, again, so you know that, in fact, the kubectl is the new root. If you give access to the kubectl, they are kind of like performing as the root user on top of the cluster. So you have to ask, especially in the at the company level, yeah, if you want to do like learning purpose, you're doing on a desktop, perfectly fine, use CLI, learn it. But in an enterprise environment, you have to always ask, why does somebody needs a privileged access to do the CLI operation? And that's we kind of like bring to you as a AppZ platform, that you can pull all the log from your applications. You have full observability of how your cluster is performing at the infrastructure level, at individual pod level. Why do you need CLI?
All right. So we'll take two more questions and then grow from there. So let's look at the next question. So, what is the ideal resource requirement for these nodes? Go ahead, Sanjeev.
Yeah, that's a that's very good questions. So when you say that, and I just want to make sure that by nodes I mean the worker nodes we are talking about here. So
Right. Right. Yeah. Let's go with that assumption. Right. So,
so the worker node that you saw, especially in this platform, that we have AppZ platform running with one master and the two worker nodes. In fact, the one which we have the standard configuration in our AWS marketplace is 4 CPU, 16 gigabyte. That is equivalent to like in AWS terminal they call it like the T3 large, uh, which suffice for the master as well as the worker node. Now this will be the kind of like the starting point, and as you add additional workloads, which is like you want to deploy the Postgres. Now the Postgres also HA have the different configurations which you can enforce, uh, like large instance and all. Then you need to add additional the capacity to the worker nodes, especially if as you run more and more application. But a starting point, I would say the 4 CPU and the 16 gigabyte is ideal for AppZ platform perspective. Now, again, if you're for learning, says like there are the smaller footprint of the Kubernetes like A3s and all, we support all of them. And for the development purpose, we can definitely go half of that. So I hope like that answered the question.
yeah, and to add to that, right? So we are planning a series of Postgres related webinars.
Yeah.
So one of the things that we are going to cover is the performance testing aspect of it. So we are going to use JMeter and PG benchmark, right? PG bench,
Yes. Yes.
PG bench, and we have images for that. So we are going to demonstrate how the performance tuning can be done on Postgres by testing using JMeter and PG Bench. So please stay tuned, and then we'll cover that in that next upcoming webinar. So one other question. So this will be the last question. So this is about um, graphical interface for monitor. So it looks like monitor kind of is playing a key role. So how do you interact with the monitor, and how do you know, and what are the options available?
I was like, there's a very good questions, and as I stated earlier, that from PG auto-failover community itself, which is the Citus data and now owned by Microsoft, like they don't provide any, and their entire solution is based on the Postgres technology itself. So there is a monitor node, and I don't think like they have a like UI version of it, and with the assumption that any Postgres browser will can serve as a like a UI for the monitor node, and that is what we did in this case, which is the adminer, which is a generic, which is the PG, the next version of the PG admin. Many of you are familiar with. We simply bring that interface on our platform, and which is accessing the monitor node and showing you that what those three tables are: node and event tables. There are a bunch of functions which orchestrate this whole HA failover and all. So Adminer, or if you are familiar with any other tool, but remember, like once you go into the cloud and the private network space, it becomes a complex challenge to integrate your desktop tool with the database running in the private network. And Adminer and that solution we tackle using providing the PG Adminer image and putting it right very close to the uh, RDS, or like the database, in this case the PG auto failover, and exposing it through an ingress URL, as you saw that Adminer URL.
Awesome. Hey, thanks, Sanjeev, and thanks for everyone joining today. It was a really good session. Thanks for all the questions. please stay tuned for the upcoming Postgres related webinars. Thank you very much.